This is the first projectile motion lab, so the object will be launched horizontally first. I'll encourage you to read through the lab on your own first. Then the first step you will do is looking into the preliminary problem. So think about what we talked through the past week about two-dimensional motion. Then we will get into a lab demonstration. So this is how I set up the demonstration. This is a projectile launcher. So in order to make sure the object is going to be launched horizontally, so I make sure the corner is aimed at 0 degree. And that is connected to LabQuest and to my iPad, which will give me the information that I need for this lab. Before any demonstration, I do need to make some measurement. First, I measure the table height, which is 86.4 centimeter. So for this lab, you might want to convert 86.4 centimeter into meters. You can fill that in table. So this is the information also given by the projectile launcher. As you can tell, from the base to the middle where the object will be launched, that's what we use at table offset, which is 0.08. So you will fill in 0.082 meter in table 2. Next, I need to go back to table 1 to use the app to showing me what is the velocity when the ball being launched. So projectile launcher is using the pressure that I can hand pump the air in there, so increase the pressure in the projectile launcher. You might wondering, how can I keep the velocity consistent as I do in the experiment? So in the middle button, there is a range. So as long as I don't move that, so the projectile launcher will make sure that every time they have the same air pressure in there. So here I would do a first demonstration. So you have the metal ball. I will place the metal ball inside. Make sure I push it all the way and then recheck my angle is still at 0 degree. Then I will use the hand pump air in there to increase the air pressure until I cannot pump the air anymore, that I hear there's some air releasing from the gauges. Then I'll wait for a few seconds. I am going to place the bucket right in front, so that way the metal ball will not just fly away. Press aim and launch. So as you can tell from my iPad or through the app, it shows me that the launching speed was 3.838 meters per second. So you might want to record that down into your table 1. So I am going to keep doing the same procedure 10 more times. So after 10 trials, I got 10 different velocity when the object was launched. You do need to use those data points to find out what is the maximum speed, what is the minimum speed, and also the average speed. After you finish table 2, then move on to table 3. At this point, a few questions you need to ask yourself. What is delta y? Which is the displacement vertically. So the metal ball was launched from the projectile launcher. The metal ball was on the height of the table, but also have to plus 0.146 meters. And also for table 3, there is predicted floor distance. If you're going back to the diagram, so the predicted floor distance is equal to predicted range subtract the table offset. So please show all your work for the predicted range for average speed, maximum speed, and minimum speed. After the calculation for table 3, using the average speed, maximum speed, and minimum speed, I find out that my predicted range is less than 2 meters. So then I mark the floor with blue tape. So each blue tape is a meter apart. Since the predict range is less than 2 meters, so I place the white piece of paper on the bottom and then carbon paper on the top in the area that I predict that the metal ball will land in. So after removing the carbon paper, as you can tell, every time where the ball was impacted on the carbon paper, it left a black mark. So now I can go to measure the distance, placing the meter stick right by 3 dots. As you can clearly see, first trial was 1.657, second trial 1.661, third trial is 1.667. You can fill into the last table. Just be aware, the number or the data point we got is for the floor distance. The range is actually the floor distance plus the offset. After finishing table 4, you do need to finish all the analyzed questions, also include number 5. You can either use the floor distance or the range for the percent error. Just make sure that you use the consistent data point.